On Granada, in the south of Spain. I work in the University of Granada. Rubén works in a company focused in free software called Fosdem. And we are going to present our project that we are developing to the Rubén thesis, because Rubén is studying, starting his PhD at the University of Granada, and he's developing a simulator that tries to emerge literary plots from a self-organizing system. Okay, we call it, actually Rubén called it made massive artificial drama engine. You can follow us in Twitter and send us an email and everything. Okay, we are going to start the problem that we are going to address. We are going to talk about the archetypes. We are going to present a methodology to develop in our project, and finally a complete example on how it's implemented inside MADE. Okay? Are you familiar with Skyrim? Who here has played Skyrim? A lot of people have played Skyrim. Do you know this guy? Do you know this guy? You are wandering and looking for loot and fighting enemies, and you find this guy. Oh, I used to be an adventurer like you until I received an arrow to the knee. And you say, oh, but you are, I really sorry. You continue fighting enemies and you go to another city. Oh, I used to be an adventurer like you. Then I received an arrow to the knee. Okay, you too. Oh, it's a pattern here, I think. You continue killing and everything. Oh, I used to be an adventurer like you. And you say, okay, it's not very immersive. Okay, maybe this is just a game and not real life. Okay, so the idea is how to develop these characters to get an interesting literary plot. Because usually these characters, you know, are currently they are scripted by hand. But if you have a lot of, maybe hundreds of non-player characters in games, it is very difficult to create literary plots for all of them. So our idea is present a method to automatically emerge the literary plot. We program the non-player characters with some parameters that emerge the literary plot. Okay, do you know what archetypes are? An archetype is a literary concept universally recognized. For example, the fall. An hero rises and then he commits something evil and he has to be redeemed. For example, Darth Vader. Darth Vader was a hero and they fall in the dark side of the Force, and then he killed the Emperor and he turned good again. Or the other very common archetype, the hero. His son. He started like a farmer in an ancient and very stupid planet full of sun, and he became a great hero. Okay, there are archetypes that are present in a lot of histories. In every history you see or read or watch the movie, there are archetypes universally recognized. Other archetypes, for example, the travel. Bilbo Baggins is in his house and just smoking and weed and that. Sorry, I apologize. I get a bit nervous. So, other archetypes are the travel. Bilbo Baggins, for example, is a normal guy. He starts a travel, and when he came back to the Shire, he's a new person. He's more mature. Other archetypes, the old wise man, like this one. For example, Obi-Wan Kenobi is the man you are going to get some expertise and advice. He advises you, and you become a hero thanks to him. The stepmother. How many stepmothers are in the histories? A lot of stepmothers. Usually they are bad. And for example, the Hamlet archetype is very present. For example, the Lion King. Lion King is Hamlet with animals. So there are very patterns, very recognizable in a lot of books and movies and games. So, based in this idea, we want to model this existing archetype that we know that works, because everybody are using them, and models the agents in a simulated environment. For example, a video game. In our case, we are starting with our self engine. We have also to measure how these stories and archetypes are emerging. Then we are going to use the parameters of the agents. For example, I don't know, the hungry level, the anger level, the relationship with other agents, etc. And optimize these parameters with a genetic algorithm to allow the story emerge in our system, or in a video game, or in something. Okay, before I start, do you know anything about genetic algorithms? Yeah, sure. Yeah, everybody knows. Well, for the one that doesn't know what it is, there are optimization methods, stochastics, that population based. There is a lot of using NP problem optimization, and well, there are a lot of conference books and everything. They are very easy to understand, but it's not the scope of this presentation, so I'm going to skip it. Finally, we are using this system to write scientific papers, because I am from the university, and you know what happens in the university: publish or perish. So we are focusing in write papers. So we are using this methodology and system to create graphs like this. You know, wow, bus plots, wow, colors, amazing science. That you can write our papers when they are still under consideration in a conference. You can follow our Twitter or web when it's published. We will send you if you want. And now this is time to play with the environment. Rubén is going to start.
Okay, it's my turn. As you may know, the genetic algorithms take a long time to work. So I can try to do some things here, but it will take a long time. Anyway, as a test, I will launch some things. Yes, this is NetBeans. And this is the application we have done. And, well, I will explain it later. But
now an experiment is being executed while he's opening the program, and a genetic algorithm is trying to optimize the parameters of a whole environment. Let's learn about this environment.
Okay. This is good enough. Okay. Do someone knows who is it? Who is him? He is Terry Pratchett. He's the creator of this world, and we have chosen. Well, I will start. You know, all the. We need a character, and the best approach to create a character is to choose a very basic one. So we thought about animals, and we thought that it could be very great to emerge behavior that usually are associated with human. So we thought that this is a test environment. So we thought about rats. We wanted rats that were magical, and we thought about the rats that live inside behind the invisible university in Ankh-Morpork. So this is very simple. This is a simplification of a rat. We went to the Wikipedia, and we saw what a rat does in its life, and we selected things that we thought that were important for us. So a rat can move, eat, attack, defend, escape, find a mate, have enough of spring, born and die. That's almost all. We thought that was interesting for us. So this is a finite state machine that models the things that we have done, and we have selected a very clear language that we can lately we can use to find different expressions. We can model different things to find the patterns that we're looking for. So it's interesting to remark the difference between stereotype and archetype. With this finite state machine, the rats will act like a stereotype. Each rat will act like a generic. Will have the generic behavior of a rat. So in a complex system like the one we are modeling with hundreds of agents collaborating, relating, eating, fighting, we think that we want to model we think that this stereotype, we are going to emerge, we are going to use the language from the finite state machine to emerge different archetypes. Okay. Okay, so as in the genetic, okay, so sorry, I'm a bit nervous. So we want to evaluate the fitness of an agent, and we have in this example, so we have done it with Avengers, for example. An Avenger is a rat. This is a model in the finite state machine. A rat that is an Avenger is a rat that eventually is attacked by other rat, and after a while this rat attacks the same rat. This is not implemented because the rats don't have memory. So well, we'll come to this later. When we execute it, we select the configurations. We run the genetic algorithm that behaves as normal. And with the configuration, the best configuration, we launch an environment. And this is, okay, we have probably 400 rats here. And we find that one rat is an Avenger. And this behavior is found in the rat is nudged by the 17, and after a while he nudged 17. So this behavior is not easy to find, and to find it, it's we have to choose the correct parameters in this silly implementation of a rat to emerge a behavior that is not that can be easily found, and that's complex relations.
Summarizing, we are going to, starting from several actions, the limited action, we want to make another actions. We model the fitness function for the genetic algorithm to measure the actions we need. So the parameters of the individuals are obtained, and we can use this set of parameters in a video game, or for example, from this log we can emerge an story, basically converting with Perl from these words to more literary ones.
The areas we have used are those one. The most important is JGAP, that is the framework we have used for the genetic algorithms, and the software is GPL, and we have developed it in JavaFX, the GUI.
That's the reason why it's so slow.
No. Okay, so maybe it's not so slow, and it's doing things, yeah. So we
can see how the fitness, the number of Avengers in this case, are emerging in this population.
Yeah. So this is a beta version, an alpha version. So in the roadmap we have many items. For example, in implementing more complex agent and archetypes, importing and exporting to real game engines. Of course, for example, we can do it with Skyrim.
For example, Skyrim has a valuable library for modding. You can combine some kind of thing with this.
As Nicholas
to avoid
said,
this, our friend, the adventure, the former adventure.
As Nathan said, the literary interpretations, and obviously all the other ways of matching the behaviors. Right now we are doing it with regular expressions that are very powerful for it, but maybe semantic social network analysis and graphs and so on could also help. Okay, that's all I think. And you can follow us on GitHub and follow us on Twitter. And if you want to contribute, yes, tell us. And thanks to all. Do you have any question?
Maybe I missed it. But so you model a rat, stereotypical rat, at the finite state machine.
Yes.
And then you produce a population of one that example with 400 rats.
Yes.
And then you let them run. Essentially, you look for the Avenger archetype and how they behave.
Yeah.
But in a genetic algorithm kind of sense, how are you permuting individual population members recombining those artifacts to produce.
Okay, the idea is every chromosome in the genetic algorithm has the set of parameters that model a rat. We have several experiments modeling several types of rats. So the chromosome is bigger, or we call this profile, is the number of different parameters for rats.
Yeah.
And these are normal vectors that recombine like a normal genetic algorithm.
Yeah, in this case, we use 12 parameters to model. Yeah, these are the characteristics, the features, and also the probabilities to make decisions.
Yeah, to move from any state of the finite state machine.
Weights of the
Yes.
Every rat, so all your characters that you are defining, when you say that you want to define an archetype, so basically all of the rats have a history.
Yeah.
So basically each of one of those rats will tell you a history of what they are like.
Yes, that usually is a very
That's the
boring
key.
history.
I'm quite interested, so how you form that history, because for example, if you have a rat that becomes Obi-Wan Kenobi, and obviously he's a consultant, so
Yeah.
I'm kind of hero, I'm going to become a hero, and I'm going to speak to Obi-Wan
Yeah.
Kenobi rat.
Okay.
And I want to know, he obviously will tell me some samples of his life, how he beat the almighty rat using the force, or blah,
Yeah,
blah,
yes.
blah. So all that history is, you have a lot, so I can read that history.
Yeah.
Into
Yeah.
that into the software.
Yeah.
Can you put a sample of that?
Yes, put
Yeah.
the log.
Okay. I still have to make improvements. We can run one, for example, this one is good enough, maybe. And here is the log of the rat.
So that's what the rat does.
Yeah, in his life.
So when you say move, the rat is moving in a virtual terrain.
Yeah.
Yes.
And of course, if he wins the battle, he will swear to that he won the battle. So just now, the only challenge is to get all that and tell literally in a story
Yeah.
that will be
Yeah, this-
more ritual.
This is
That's
the
the
challenge.
next step. Starting from here, we have to write something beautiful,
Yeah.
something.
In the roadmap.
And when looking at this next step,
Yeah.
how can you prevent the I got shot in my knee problem? How can you prevent this from happening
Yes.
like 500 times? How can you get enough things so that you don't get duplicates in a huge world if you're looking at something Skyrim-like, where you have like 1,000 NPC characters or something like this?
For example,
How
we
can
have
you prevent something from this?
Yeah, we can add in the fitness value to search for different archetypes, to force different archetypes emerging. So if, for example, we have here several Avengers, but we can say, okay, the fitness function that models this environment penalize the algorithm several archetypes at the same time. So you have to maximize different archetypes. Fitness function and genetic algorithms, there are another theory about restrictions and guidance that we can apply in our algorithm. Initially, it's a very basic one, but the idea is to, and this is the first experiment we are.
Anyway, the most important thing here is that we are trying to model the mood of the story, not the how they will act when you find them, but the background of the backstory of the characters.
But doesn't this offset the scripting of the individual characters to designing the fitness function? So I think in the end, if you need 20 different NPCs, you still have to have 20 different fitness functions. And you have to
Well, no, not at all, not exactly. The idea is to develop some kind of history one, for example, a territorial war, or Romeo and Juliet. We maybe don't set a fixed number of archetypes, but to see the algorithm, what the algorithm decides. So I want in this game the Romeo and Juliet history. How, for example, being in love with two rats that are different families. You don't have to say you are from the Capulets and you are for the other ones that I don't remember. so Montesquieu. So the idea is you define a global history, and the system automatically selects you are Capuleto, you are Montes, you are Romeo, you are Juliet, and this history is emerged from the execution. So you are playing, and the other guys are working while you are playing, for example. So the idea is not to model every archetype to all the characters in the game, but maybe 2 or 3 or 4, and with these 4 archetypes generate others, for example.
And it's important to remark that this process is iterative. So maybe you have to redesign the agents to fit to a language that lets you create an expression that lets you match and behavior and iterate and iterate.
Another question?
Is there any way, for example, if you want to introduce a pre-generated character or agent inside the already living?
We can maybe add another finite state machine. For now, we are using one kind of finite state machine. We can add several state machines.
But I mean, also with a complete history. For example, if you have your own game world, and you know there are going to be those main characters, and you want them introduced inside the world, so all the other evolving agents are going to interact with them.
Well,
is it possible?
Yeah, in future, in future, as I said, it's the first experiment we are. But the idea is that the main character needs to interact with the.
Even let the author to create his own.
Please wait a little
agent.
until the talk is finished before you all come storming in.
So the idea is, this is the first thing that Rubén has made. He has 4 years to finish his thesis, so we have still 4 years to work hard. I'm sorry, I can hear you. How many actions?
15 actions, I think.
Yeah, and add more and more complicated.
Yeah. But the complex, the more complex it gets, the difficulty, the more difficult is to find, to model, or the chromosome will be bigger, and the solution is more difficult to find.
For example, for a big video game, it would be really nice. For example, it's just like a render. So
Yep.
you make a render, okay, it works great, you can spend a month
Yep.
computing. So you have all the background stories, you have a real media to start a really interesting game.
This is the goal.
In those actions, do you include communication actions?
Yeah.
Or
Yeah, they communicate with the environment, and the environment communicates with the neighborhood. So you can contact with all an agent can contact with other agents through the environment. Yeah.
Any other question? Okay, thank you very
Thank you.
much for your. Thank you. Yeah.